Hey everybody, in this video we're going to look at a chi-square test, and that's what we covered in class this week. And this is actually a partial review and an extension of what you learned a few modules ago in Module 8. Um, so I'm actually going to scroll down to that section and then I'll start explaining it. So in that section, we were looking at the relationship between two categorical variables, and the chi-square test is the hypothesis that tests the hypothesis that these two variables are related, and then the null hypothesis would be that there's no relationship between those two. So I'm going to actually recapture what we spoke about earlier in that video, and we'll just extend it to do the chi-square test. Okay, so the first thing that we'll do is look at to see if there is a statistical relationship between a patient's sex and returning readmission to the hospital within 30 days. So we'll start with our table, and remember that you would put things in slightly different orders, but we'll start with the um, we'll start within we'll do gender in the to the right, or to the second one, and return 30 here to start with. And we'll just create that table because we do want to do that same mosaic plot to try to understand that relationship. And when we display that, you can see that again, you had the largest group was males who were not readmitted within 30 days, and it was evenly split between males and females for those who were readmitted. And so we can look at that mosaic plot. We'll keep that that V table because we just stored, the vector that instead of having marital status and gender, we kept it with, now we changed it to return 30 and gender. So we'll put in, we just have to readmission. We have to make it make sense, right? Readmission by patient sex. And we will put on the x-axis readmit within 30 days. We'll see if that works for us. Okay. And that did seem to work because the label sex is next to male and female, and our readmit within 30 days is the yes and no. And we pretty much see that, again, what we saw before, an even split between those who are readmitted between males and females, but those who were not readmitted were more likely to be male. Now we just need to make sure our G models package is required. We have that reminder here, and it is. And so we will switch the order that we had that in. It just makes it a little bit easier. Now it's still the same function that we used before, but now we're going to put in the option to do the chi-square test. So after the return 30, we're going to put chi-square. Now we can select this here, equals t. That's telling us it's true that we want the chi-square test. So it's going to look just like the cross table function that you saw prior. However, it's going to give us the results of that chi-square test as well, as you saw in your book. Okay, so just as a reminder, this is the count, the 50 and the 14, and the 83 and the 14. And the row totals are the third down. So this is based on the row. So of all the this means everything on this third row is of all the females, because the females are in the row, 78.1% were not readmitted within 30 days, and 21.9% were. and females make up 39.8% of the patient population. Of the males, 85.6% were not readmitted within 30 days, and 14.4% were. So, there's a higher proportion of men that were not readmitted within 30 days, and males make up 60.2% of our patient population. And then the column totals, the column percentages are the fourth down: 1, 2, 3, 4. So of all of those patients who did not return within 30 days, just over a third were female and 62.4% were. And as we saw in our mosaic plot, we can go back to that, half were readmitted were female and half readmitted were male, and 82.6% of the sample were not readmitted within 30 days, and 17.4% were. And here's the result of our chi-square test. Now, if it gives you a Yates continuity correction, I suggest you use it. It accounts for cell counts and so on that are a little outside the scope of this class. If it's relevant, it will be given, you will get this output here. This is your calculated p-value, the chance of making a type 1 error, which is 31.4%. That's way greater than the 0.05 threshold, the 5% threshold of denoting a relationship. So even though we observe some differences, statistically we cannot conclude that patient sex and readmission status are statistically related, and we would have to assume at this point that there is no statistical relationship because that p-value is over 0.05. So that was the first thing that I demonstrated to you last time. The second thing that we'll do is going back to that relationship between gender and marital status. So we're just going to switch return 30 to marital. And we'll run that, and we'll look at the output, which you had seen before. And again, we saw 4 groups: single, married, widowed, and divorced. And remember that divorced group, as you've seen throughout the semester, is a small group with only 4 patients in it. We'll stretch this out because it'll make this look better when we actually do our mosaic plot. And we will do marital status by sex. So when you do these mosaic plots, the word by almost always makes sense in the middle of the 2 variables because you're just looking at the relationship or trying to explore the relationship between those 2. So that's what the mosaic plot will show you. And then the X label will be marital status. And hopefully that will work out for us. Oops. I like to keep it capital. And let's run that. And again, we see that it's very small group of divorced folks. So that looks evenly split, but we can see the widowed folks are more likely to be female. And that's because the patients who are female tend to be older. You can play around with this by yourself with the age cat variable and sex. You'll notice that. And the married folks tend to be males. And then there's slightly more single females than males. And, it's exactly what you see in this table. But the cross-table function will let us know whether there is that statistical relationship. So I'm going to change in there, return 30 to marital. And again, it doesn't really matter the order in which you put this. It's just really the output, I think, is a little bit easier to see when you have more options in the rows, more categories in the rows, and you'll get it in that order with putting it second. Okay, we're going to run this. Now here you see that you didn't get the Yates continuity correction. And again, you see that the p-value is written in scientific notation. Um, by the way, in real life, you couldn't have a p-value greater than 1 because that's the percent chance or the proportion of chance um, that you make a type 1 error. So you can't have more than 100%, which would be a p-value of 1. So when you see something 1 point something, you're going to start looking to make sure that you have something written in scientific notation. Yeah, so this p-value is very low. You don't have the key like you got before, um, but you can, again, um, use that option to turn off scientific notation if you like. But this p-value is way less than 0.05. But unlike, say, the analysis of variance or t-test, it really doesn't tell you where those relationships lie. You have to sort of pick those out yourself. And we can really get a sense of this. Things, again, that are more evenly split, we don't necessarily think there is that relationship. We saw that several weeks ago when we were, I'm going to scroll through all of these and hopefully I didn't accidentally erase that. No, I don't think I did. But when we looked at colors of eyes and gender, no relationship at all looks like this. Um, so when we scroll to the end here, um, we can see that, there's probably not a relationship between being divorced and gender, not so much between being single, but we can conclude, because we have a statistically significant difference, that the married folks are more likely, there's a statistical relationship between gender of patients, or sex of patients really, and marital status for those who are married and widowed. So that's it. You again can practice reading the cell contents, and I encourage you to do so. Um, and I hope you found this video helpful. For your homework, I'm just going to extend the homework that you did for Module 8 to test to see if there's a statistically significant relationship between, I think, having a spouse and returning within 30 days. I think that was it. So I hope you enjoyed this video and found it helpful.